Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 41, which is based on rotary actuators. Rotary actuators are those wherein reciprocating motion of cylinder is converted into rotary motion of limited rotation. There are two forms of pneumatic rotary actuator. They are a torque cylinder, or it is also called as semi-motor, and the second one is single or paired diaphragm cylinders. We'll discuss one by one. Torque cylinder. It consists of two back-to-back cylinder with a common piston rod. The piston rod is provided with a rack engaging with a pinion mounted transversely in the center line as shown in the figure. Linear movement of the piston is translated into limited rotary motion. A rotary motion is usually limited to a maximum of 300 degree or less. A particular advantage of torque cylinder is that for constant applied pressure, the torque output is constant for whole range of the rack traffic. Then coming to one more type, that is called as paired diaphragm cylinder actuator. Paired diaphragm cylinder actuator is a combination of two conventional diaphragm cylinders mounted on a common centerpiece carrying a toothed wheel. Each piston rod terminates in a ratchet engaging the toothed wheel as shown in the figure. The selected diaphragm cylinder is operated in an automatic oscillating mode, driving the toothed wheel continuously in a series of progressively rotary movements. The other cylinder reverses the direction of motion. Diaphragm cylinders are essentially high thrust devices. High output torques are realized, and the type of rotary actuator is capable of continuous rotation in either direction. And one more type of motor that we are going to discuss is called as Vane type of rotary actuators. Vane actuator consists of a single vane mounted on a rotor connected to a shaft. This is a positive displacement actuator which develops an output torque at its shaft by allowing high pressure air through the ports provided in the casing. The vane rotates due to imbalance or differential pressure caused in it. The torque developed depends on the projected area of the vane and the differential pressure. If pressure P1 through port A is greater than P2 through port B, the vane rotates in clockwise direction and vice versa. And the figure shows the basic construction features and operating principles of a vane type rotary actuators. Then coming to rotary cylinders. Rotary cylinders have their cylinders rotating along with the piston as the piston reciprocates. There are two types of cylinders. They are true rotating cylinder. The true rotating cylinder is one where cylinder and piston of the cylinder are locked in such a manner that no relative rotary motion can occur between them. The complete cylinder is mounted on a distribution gland which allows the cylinder to rotate relative to a workpiece. Then another type is called as a rotating cylinder. Is one where design provides for piston to rotate freely relative to the cylinder with no loss of working characteristics. This requires the piston seal must be capable of accommodating rotary as well as sliding motions. Then coming to the next concept, that is called as air motors. Air motors are mechanical devices wherein pneumatic or air energy contained in the air received from the reservoir is converted to mechanical energy in the form of a rotary motion. Air motors in fact are competitive with electric motors, IC engines and hydraulic motors in many fields of application where power required do not exceed 15 to 20 kilowatts. They have particularly wide range of application at low levels down to and including fractional power sizes. Coming to the advantages of air motor, It is having a low cost, low running cost, low initial cost, high reliability with minimal maintenance requirements, safety, particularly for operation in hazardous areas, inherent overload protection, low inertia in case of easy control, and high power to weight ratio, can be operated continuously for longer periods and unlikely to overheat because the expansion of exhaust air has a cooling effect. And which are the different types of air motors we have? The majority of air motors are of vane type or piston type configuration. Other types also includes diaphragm, turbine and linear motors. In addition to general purpose, air motors are designed for a special functions. Now let us discuss about the piston motors. Piston motors are the most common type of air motors employed for industrial drives. Piston motors can be either inline design and radial design type. The radial design type motor is most common in application. The typical radial motor has all connecting rods mounted on a common crank, which you can observe from the figure. Power and exhaust stroke are connected by suitable distribution valves and two-stage exhaust is often adopted. Piston motors develops high strain and initial torque, falling with the increased speed. Both torque and power developed depends on the supply of air pressure. Starting, optimum running and stall torques are also dependent on the supply pressure. Piston motors with variation in design includes wash plate motors as well as face cam motors and other motors but suspended by vane motors. Then, what are the applications of the piston motors are there? Fractional power motors and which are portable and bench tools, light lifting and hoisting and mechanical handling. And higher capacity motors usually general drives with heavy and fluctuating loads requiring better low speed and torque characteristics. Coming to the next type of motor which is called as a vane motor sliding type vane type. Okay. When wave motors are generally lighter, more compact and cheaper than the piston motors available in power ranging from fractional capacity to 20 kilowatt power, their power to weight ratio is outstanding and the figure illustrates the main parts of operating principle of reversible vane motor. It consists of a radial slotted rotor mounted on a shaft eccentric to the power chamber. The vane will slide radially and seal against power chamber wall or cam. The vanes are usually sprung out either mechanically using a spring or pneumatically using compressed air against a cam spring to provide sealing force in the initial starting condition. As the speed of the motor increases, the vanes are swung out by centrifugal action. Air is supplied to pressure chamber either through ports A or B. If air is supplied through port A, the motor rotates in clockwise direction and if supplied through B, it rotates in counterclockwise direction. By varying the axis of rotation of the rotor with reference to the axis of the pressure chamber, the speed of the motor can be varied. The distance between the axis being is called as eccentricity and such a motor is called as variable speed motor. And upon applications of vane motors, it can be applied on lower capacity motor which is used for probable air tools, multiple light duty tools, etc. And for higher capacity motors, it could be heavy air tools, pump drives, and general drivers duties where light starting loads are involved. Coming to the different types of vane motors or a diaphragm motors. A diaphragm motor is basically a reciprocating device with small stroke. The reciprocating motion is converted into rotary motion using a ball and ratchet mechanism. The speed of working is low but torque produced is very high, suitable for high torque and low speed applications. Example, valve actuator. Then the other type is called as linear motors. Air cylinders are essentially a linear actuators. If adapted for continuous self-reciprocation, they are known as linear motors. This form of motion can be provided by using a conventional double acting cylinder with trip valves or similar devices would switch the control automatically at the end of each strokes and maintain continuous reciprocation. The main control may be initiated by mechanical triggering of a pneumatic or electronic triggering, and the figure shows for a continuous reciprocating motion. The reciprocating output of the cylinder may be used directly or to drive crank for a rotary output, which you can observe from the figure B. By this, I would like to conclude the session. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavarkar.